So for this topic, we are working on interpreting graphs, and these are the topics here that we're going to focus in for interpreting graphs 1. These are all foundational topics that you need to understand well. So take really good notes and make sure you're studying over these topics and asking questions if you have them. So let's get started with our first topic, the functions. We want to be able to identify whether or not something is a function just by looking at it at this point. We'll get into other things as we progress. But for right now, this function, this graph on the left is a function, and this graph on the right is not a function. And what you want to focus in on is thinking about the vertical line test. So if I was to draw a vertical line on this function on the right, okay, you can see how the vertical line hits here and here. So it's hitting the graph more than once. And that is basically failing what we call the vertical line test. A vertical line test can only hit the function one time for it to be a function, okay? So if you look on the graph on the left, I can draw a vertical line here. Oh, very crooked, sorry. It's hard to write on the screen. Or here, okay? And they will only hit the graph one time, okay? There's no place on the entire graph where I can hit the graph more than once. So essentially just make sure you're always doing the vertical line test, and if it passes the vertical line test, then it is a function. So we'll go through these 4 examples quickly here together. This first graph is not a function, just like what we just discussed. The vertical line hits more than once. The second graph, yes, is a function. Okay, you could do a vertical line test anywhere on there, and it only hits once. The third graph is also yes, a function. Okay, do your vertical line test. And lastly, this one is no, because there's obvious lots of places where the vertical line hits more than one time. Okay, so that's it for functions. Let's keep going here on to one-to-one. All right, now a lot of students have never learned much about one-to-one, but this is a concept you need to understand. And first off, you need to make sure that you do pass the function test, all right? If you are trying to determine if something is one-to-one, it first must be a function. So you give it the vertical line test, and then if it passes the vertical line test, then you give it the horizontal line test, all right? So your horizontal line test is going to come through like this, okay? And you can see how this guy right here is failing the test. It is not one-to-one, all right? But this one on the right is passing the test, okay? So it is one-to-one, okay? So one-to-one is a topic that will be important once you build into calculus. So we are trying to expose you to these ideas so you've seen them and have an understanding of what that means. So we're looking at each of these to determine if they are one-to-one. Okay, so this guy here passes. So yes, it's one-to-one. And these are all functions, by the way. So they've all passed the function test. Okay, and this next one here, the horizontal line test would fail. So it's not one-to-one. Horizontal line test fails here, so no, not one-to-one. And horizontal line test fails here, so no, not one-to-one. So this was the only one here that passed the one-to-one test. All right, so let's move on to domain and range. Okay, now domain and range will be a topic that we work on until the very end of the semester, and we're going to build on the topic. So as we get further down into the more complicated topics, we'll build in the more complicated domain and range. But for now, you're just trying to understand what it is and how to recognize it. So domain in general, okay, domain is going to be, you want to think about that being your inputs, input values. We usually think of that as your x variable, and your range, all right, is going to be your output, which we usually think of that as the y. Remember, you don't have to use x and y, but most people identify with those variables. And you have to think about the x and y values separate from one another, which is kind of tricky with your brain, right? So let's do the domain in green here, okay? So if I look at this graph, I have an x value of -5, and then it continues, and then I have an x value of 2. So my smallest x value is -5, and my largest x value is 2. So I'm using all of these x values between -5 and 2. Now, you also have to think about the interval notation and how we're going to write that. So with interval notation, in this particular example, I would say bracket -5, comma 2 parentheses. Okay, I'm using a bracket on the -5 because of this closed circle, okay, and I'm using a parenthesis on the 2 because of this open circle. Okay, so a bracket means we are including the -5. The parenthesis means we are actually not including the 2. We're just including everything up until the 2. So we're including points like 1.99999, something very, very close to 2, but actually not including the 2. All right, so let's switch to the range, and I'm going to erase these marks just so we can work with a cleaner surface here. And I'll change to, let's change to yellow. Okay, so range, all right, is your y values, obviously. So we want to think about, I have a y value of -7, and I have a y value of 3.38. So my range is using all of the y values from -7 up to the 3.38. Okay, so you want to think about these values along the y-axis. Now, once again, we have a closed circle here, but we have a closed circle here. Okay, so I can use a bracket on both ends. So I can say bracket -7 to 3.38 bracket. Okay. Let's do another example with domain. Okay, so here we have a graph that's given, and it is okay to assume that this graph continues forever. Whenever a graph goes to the edge of the graph paper, like you're seeing it do here, and they're not indicating anything other than the fact that it just keeps going, you can just assume that it is going forever. So your domain is actually going to be all of your values that exist on the x-axis. Okay, so once again, I'm doing my domain in green. Okay, and since this goes on forever, you have to think about the fact that it's going up and it's going to the left. Okay, so it is going to use all of these values forever this way. Okay, because it's always going up and a little to the left. Okay, and then over on the right side, it's continuing to go up and it's continuing to go to the right. So it is going to keep using all of those values. Okay, and it's obviously using the values, right here on the actual curve that you're seeing. Okay, so we say this is -infinity to +infinity because it goes on forever in the negative direction and it goes on forever in the positive direction. And you always should put a parenthesis on your infinity, okay? Goodness, having some issues with the cursor today. So with the range, you want to switch to thinking about your y values, okay? Now I do have a y value of -4, and that is the lowest that the graph goes. So that's going to be my smallest y value. And then I want to think about the fact that I'm using all the y values forever and ever that way. So it's forever going to continue. So I am using -4. I can put a bracket on that, and it goes to infinity, positive infinity. let me highlight this in yellow. Okay. All right, so we will practice with domain and range a lot. Okay, so if you're a little shaky on it right now, don't panic. You're going to see it a lot more before the Module 1 test, but keep working on it and ask questions, okay, to get clarification. So evaluating functions and function outputs is another topic that you need to understand. And this graph over here on the right is the graph of f, that's the function f, and we are evaluating these different values. Okay, so f of 1 means that we want to think about an input value of 1. All right, so that will be an x value of 1 and what happens on the output there. Okay, so we're going to go over to our graph and I'm going to go to the x value 1 and then I'm going to find the graph. So this is this point here. And I'm going to think about what that point is. That's the point 1 comma negative 1. Okay, so at an x value of 1, I have a y value of negative 1. So the answer to this is negative 1. So they're giving you the input and you're basically just trying to find the output. Okay, so let's look at an input value of negative 4. So go to your graph, go to the x value of negative 4, find that spot on the graph that has that x value of negative 4. Think about that point, that's negative 4, 0. Okay, so when we have an input value of negative 4, that output value is 0. Okay, and so the answer to that is 0. So really all you're doing is just thinking about a point, right? They're giving you part of the point and you're trying to find the other part of the point. Okay, so for part C, okay, let's go down here and think about what this means. They're saying, okay, what is the x value when you have an output of negative 3? So you're looking for this input value when you have an output value of negative 3. So go to your graph and think of negative 3 and find that spot on the graph, okay, which is going to be right here. Okay, and then you want to think about what that point is. So I think it would be safe to say that's like negative 4.5, ballpark, right? We're kind of having to guess a little bit right there. Okay, but that is the answer that we're looking for right there, is that negative 4.5. So here you would say that x equals negative 4.5. Okay, because that is the input value that gives you that output value of negative 3. So for part D, okay, we are going to think about when do we have an output of 0? Okay, what x values give us this output of 0? So I'm going to switch to, let's see, I'm going to switch to a different color here, maybe green. Okay, so when I have an output value of 0, I actually have two spots. I'm going to do these in green here so they'll stand out. I have two spots on my graph that have an output value of 0. So I have an output value of 0 at negative 4, 0. Okay, so I can put a negative 4 in there. And I also have an output value of 0 at 0, this other point 0. Be very careful here that you don't say this point, okay, this point 2, 0. And what is happening there, remember, is there's an open circle, okay, this guy right here, that's an open circle. So you cannot actually include that, okay, it's kind of tricky, right, because they're identifying that point on the graph, but because of that open circle, you actually cannot include that. So we will say for our answer here that x equals negative 4 and 0, okay, and do not list the 2, but you can list the negative 4 and the 0. Okay. All right, let's move along to the greater than, less than. Okay, so when you're reading a graph, One of the things that you're going to need to be able to do is figure out when it is greater than 0 or maybe less than 0. Okay. So actually, let me change that to a different color there. Let's see, bear with me here. Really, cursor is really acting crazy today. I'm going to do less than 0 in green, and I'll do greater than 0 in yellow. So less than 0 is going to be when you're below the x-axis. So the graph is below the x-axis through here. Okay, and they're talking about below the x-axis when over here in this part. So this is the interval -2 to 1. Okay, and notice they are just using those x values, okay, when they write that interval. Okay, greater than 0. Goodness, okay, is this part of the graph up here. Okay, that's where it's above the x-axis. Okay, and this is what they're talking about over here in this answer. Okay, and the interval -∞ to -2 is this left part here, -∞ to 2. Sorry, -2. Put the negative sign in there. And this right over here is the 1 to infinity. Okay. Notice once again, they're just using these x values to write the intervals. Okay. So let's do some more together here. So greater than, less than 0. Let's see, what colors did I use before? Greater than was yellow. Okay, so I'll stick to that. So in this graph here, I am greater than 0 on that part and that part. And on this graph over here, I am greater than 0 for all of this part. Okay. And for less than 0, we're going to have this part and this part. Okay, and over here, I don't have anything less than 0. Remember, that would have to be below the x-axis. Okay, so now we just have to write the intervals. Okay, so for f of x less than 0, okay, that's the green part. That's when we were below. I have two green sections on this graph. So I would say -∞ to -4. That's this interval here. Okay, and I would put the union symbol, and then I'd write this one. So that would be 0 to 7. Remember, just use the x values. Okay. Now for f of x greater than 0, I'll try to squeeze it in down here. I'm going to write the yellow section. So I have to do this section here. So that's -4 to 0, just using the x values, and union this section over here, which is going to be 7 to infinity. Okay. All right, moving on to this graph here. For f of x is less than 0, that's none, okay, or no solution. Okay, there's no green part on this graph. There's nothing below the x-axis. And for f of x greater than 0, it's the whole graph. So you just say -∞ to +∞, representing the entire domain of the graph is all above the x-axis. All right, so our last topic that we need to discuss for this interpreting graphs topic that we're working on today is these basic functions. Okay, so you will also hear these called parent functions. Okay, and these are basically, the most popular, most commonly seen functions, especially in our class this semester. So you need to learn each of these functions. Okay, you got linear, quadratic, polynomial, root, radical, exponential, logarithm, and absolute value. So you first want to just look at, learn how they look, the general look of each one. And then we will get more specifically into identifying their domain and their range and other characteristics, okay? So your linear functions always just look like a line, okay? So those are pretty easy. You could have a horizontal line as you see here on the left, or it could be a slanted line as you see here on the right, okay? But they just always look like a line, okay? Your polynomial functions are going to have some curve to them. Now this is a special type of polynomial. This is your quadratic, okay? And it always has that U shape, and it always has an x square, okay, in the equation. And this is your cubic polynomial over here, and it always has this kind of curve look to it, okay? And it always has a cube on it, okay? You can also have polynomials that kind of look like a roller coaster, right? Like this, or maybe like this, okay? Those are also polynomial type functions. Okay, so root functions, sometimes these are also called radical functions. Okay. So this is your square root function, and we put the 2 here just to emphasize it, but most of the time you'll just see that as square root of x because the 2 is understood to be there, okay? And they always have this definitive stopping part and then shoot off one direction, okay? And this is your cube root function, and it keeps going on the left and the right. So it kind of looks like you put 2 of the radical functions together, okay? Rational functions, and sometimes these will be called reciprocal, okay? They have multiple parts to them, so you can see you have 2 curves here, okay? And this one we have 2 curves. Now on the left, the 2 curves are opposite from each other. But on the right, you can see they're side by side, and that can happen, okay? And then we have our exponential functions, okay? So exponential functions always have what we call horizontal asymptote. So I'm going to put HA here. And the horizontal asymptote is coming across right here on the x-axis, and it's steering that graph to the right, okay? And on this one, you have a horizontal asymptote on the x-axis as well. So I'll put that over here and write it out, horizontal asymptote. Okay, and basically your exponential functions always look like they're leveling off on one side. It could be the right side or the left side, but they're leveling off. Okay. Absolute value functions always have this V look to them, so they're always easy to point out. Plus, you'll always see the absolute value bars in the equation. And we also have your logarithmic functions. Okay, now logarithmic functions have a vertical asymptote. Okay, so we have this vertical asymptote right here on, and it's coming down that y-axis, and it's steering that graph down. Okay, so let me write this out here, vertical asymptote. Okay, and logarithmic and exponential graphs are very similar, and there's a reason for that. We'll talk about that as we get a little bit further into the semester. But you will notice that your logarithm graphs have the vertical asymptote, whereas your exponentials always have that horizontal, okay? Logarithm graphs will have that log in the function name, or you could see it as like ln of x, okay? That's another way to express a logarithm. We'll talk more about that as we progress. Okay, so that's it for this video. Study over these notes and watch the video again if you need to, and I'll see you in the next video.